Hello folks, welcome back. It's been a while since I have recorded my last video and so welcome back once again to my channel and thanks for subscribing. Hopefully you have already done that. So with that being said, today we will be covering what are basically bitwise operators. So we have been at operators for quite some time now. So we have already covered the arithmetic operators, then relational operators, ternary operators, right? So the part which is pending for us to cover is the bitwise operators, the logical operators, and the shift operators. So in this particular lesson, we will be kind of tackling what are the bitwise operators, like what is the bitwise AND operator, OR operator, then XOR operator, bitwise complement operator. So we will be seeing all of these operators in this particular session. So without any further delay, let's get started. So what we see here is one more class. It's called operators demo and it has a main method as we can see here. And within the main method, we have defined two integer variables a and b with respective values of 15 and 12. So what are bitwise operators? So bitwise operators are operators which actually works on the bit representation of the number. So let's say we have this variable a and we have this value of b, right? So 15 is written in this form, 0, 0, 0, 0 and 4 ones. So this is the binary representation of 15 and same goes for 12 as well. So now let's say I want to do a AND operation, a bitwise AND operation between these two numbers. So how do we do that? That AND operation will take each of these bit pairs, right? Which is matching with their significant bit positions, and then it will do the operation and come up with the result. So let's say I want to do a bitwise AND on A and B. How will that work is, first we have to take into account the binary representation of A and the binary representation of B. Then proceeding from the right side towards the left, we will take one bit at a time and we'll perform the operation on each of the bit pairs. So in AND operation, we know that if both the bits are set, then only the output is a 1. In any other condition, the output is a 0. And for OR operation, we know that if either of the bit is set, the output is 1. So that means only for 0 and 0, the output is 0. Everything else will provide a 1. For the XOR operation, what it means is, let's say the either of the bit is set, but not both the bits at the same time. Then the output will be a 1. So let's say a 1 and a 0 will be a 1. A 0 and a 1 will be a 1. But if both are zeros, that will be 0. Both are 1s, it will be a 0 as well. So that is XOR. And bitwise complement, we all know. Bitwise complement will just toggle the bit position. So if it's a 1, it becomes a 0. If it's a 0, it becomes a 1. So with that in mind, we will kind of go ahead and try to understand this code. So what I'm trying to do is I'm doing a bitwise operation of AND on A and B. So 15 and 12, if you do a AND operation, right, what would be the output? So if we go with this example, so 1 and a 0 is a 0, 1 and a 0 is a 0, 1 and a 1, 1, 1 and a 1 and is 1. So the number will have the fourth bit position and the third bit position from the right side set. So that is a 12. So the output should be 12. So if we run this code now, so I can see the first output is 12. Now proceeding to the next one, which is a bitwise OR. If we do a OR operation for each of these bit pairs, what is the output? So we have a 1 and a 0, which is a 1. Then 1 and a 0, again a 1. 1 and 1, again it's a 1. 1 and 1, again it's a 1. And rest of it is 0. So the output would be 4 zeros and 4 ones. And what that basically is, it is 15. 8 plus 4 plus 2 plus 1, it is 15. So as we can see in the output also, it is 15. Moving on to the XOR operation. XOR operation will take into account that either of the bit, if it is set, but not both of them at the same time, output will be a 1. So 1 and a 0 will be a 1. Then 1 and a 0 again will be a 1. 1 and 1 will be 0. 1 and 1 will be 0. And each of these will be 0. So in this case, only the second and the first bit from the right side will be set. So the output will be 3. As you can see, the output is 3. Now coming to the bitwise complement, so now here we are complementing the value of A. So the representation of A is this. Now if we complement this, we will get 4 ones and 4 zeros. So this representations, since it has the sign bit now set, right, the most significant has become a 1 after the complement operation. So internally, this number will now be treated as a negative. So we will be getting the binary representation of the 2's complement representation of that number, which is a minus 16. So that's the value that we are seeing. So minus 16 is nothing but first you write the representation of 15, then you complement or just toggle each and every bit which is there in 15's representation. Now that would set the most significant bit, that is the leftmost bit will be set, making the number as negative. Now when Java tries to print that number, it will not treat the number as a 15 or a minus 15 because it is some other number which is being represented as a minus, as a negative number. So that representation will come up as 16. So the number becomes minus 16. So hopefully this made sense. You are able to now understand what are the basic subtleties between each of these bitwise operations. So we'll try to quickly explain why negation of 15 from our previous example turned into a minus 16 when we printed it out in the integrated console of the IDE. So why that basically happens is, when you negate 15, right, what happens is its 32-bit representation actually gets negated. That is, each of those 32 bits get toggled. So the 32-bit representation of 15 is like this, right? So only the first 4 bits are set to 1 and rest of all the other bits are set to 0. Now when you do a complement of 15, we see that each of the bits get toggled. So the ones which were set to 1, that gets toggled to 0 and the zeros are toggled to 1. So now this is how negation of 15 is getting stored internally. Now when Java tries to print it, what it does is, basically this representation is of a negative number. Now how I can tell that this is a negative number? Because the most significant bit is set to a 1. So that means internally Java is thinking that, okay, this is a negative number. So whose negative number is this, right? So how do you find it out? So Java does a 2's complement of this above number when printing it out. So if you do a 2's complement, so if you have not already referred to the previous lecture that I did on how to find 1's complement and 2's complement, I would again ask you on to kind of go and revisit that lecture to understand how we calculate 1's and 2's complement. So basically, just as a refresher, what we do is we start from the right side and continue towards the left, and the first set bit that we encounter, we keep it the same, and then proceeding from that point towards the left, we toggle all the bits which are set. So basically, if this is the number, its true's representation will be 4 zeros will be copied as it is. Then we encountered the first set bit, so we put that number as it is and then toggle all the numbers which are here. So as you can see, all the numbers have been toggled except the most significant bit. So now if you see what number is this is basically 16. So this is the 5th bit. So 5th bit is 2 to the power 4, which is a 16. And this one contributes to this negative sign. So that's why Java was printing minus 16 in the integrated console. Hope that made sense. Thank you. So that's all that we needed to cover as a part of this lecture. So moving on, we will be discussing the shift operators and the shorthand assignment operators in our upcoming and hopefully the last lecture that we will be tackling in Java operators. So until then, thank you and thanks for your time. If you haven't subscribed already, please go ahead and subscribe. That helps us out a lot. Well, thank you. Until next time. Bye.